this session we can start some important questions for class 12 CBSE mathematics. So first question, so this is from relations and function. Set A is given as 1, 2, 3 up to till 9 and R be the relation in A cross A. So first we have to see what is the meaning of relation in A cross A. First, relation in A means, and we know the basic concept, relation is nothing but subset of Cartesian product A cross B. So relation in A is nothing but subset of A cross A, subset of A cross A. So relation from A to B means, relation from A to B, this is nothing but subset of A cross B. And relation from or relation in A cross A is nothing but subset of A cross A cross A cross A. So this is the meaning we have. And now here they have given this statement only, relation in A cross A. So which means this we have to take. So the elements in this set A cross A is an ordered pair. So here the elements in A is nothing but just 1, 2, 3 like this it will be there. So in relation in A cross A it will be like this. I'll write some of the elements in A cross A. So I can have 1, 1, 1, 2, 1, 3 till 1, 9. Next I can have 2, 1 till 2, 9. Like this it keeps on going here 9, 1 till it will be 9, 9. So these are the elements in A cross A. Relation in A cross A is nothing but the subset of A cross A cross A cross A. So which means here what I have to take here is, here they have mentioned the relation A comma B set itself. If I take this one, so it should be 1, 1 should be related with 1, 1. So this will be reflexive if we have, and 1, 2 should be related with 1, 2. So which means this entire thing is an element. So reflexive is nothing but A should be related with A. So whatever here we have written, it should be related with itself. So which means if I write 1, 2 here, so 1, 2 should be related to 1, 2 itself. Suppose if I take this element 1, 3, so 1, 3 should be related with 1, 3. So if I take 1, 4, so 1, 4 should be related with 1, 4. So this is the meaning of reflexive here. So reflexive is nothing but whatever element if I take from A cross A, it should be related to itself. So which means if I take 2, 9, so 2, 9 should be related with 2, 9. Each and every element in set A cross A should be related to itself. So if it is like this, then we call that relation as reflexive. Here they have defined the relation A comma B is nothing but they are taking this from A cross A. If they are taking this A comma B from A cross A, which means A belongs to set A as well as B also belongs to set A. So here this C comma D also they are taking from A cross A. So which means this C belongs to set A and D also belongs to set A. So this is the basic concept we should know. So now coming to the question. So these are just the concept. It is not part of the answer. So just I will erase this, or I will keep this here. So now we can start this question. So here now we know what is A cross A. So A comma B is related with C comma D if and only if A plus D is equal to B plus C. So now we have this relation A comma B related with C comma D if and only if A plus D is equal to B plus C. So now I have to check A comma B related with the same element. This entire thing is one element related with A comma B or not. So if it is related, so just I have to add this a plus d. I have to just check whether a plus d is equal to b plus c or not. So here in this case, first and here second, so a plus b equal to here second and from here it is first, so b plus a. Yes, addition is commutative. So this is a, b, c are just the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So till 9 I can take any number. So here if I take suppose 1 plus 3 will be equal to 3 plus 1. So addition is commutative. So which means a plus b will be equal to b plus a. I can say it is reflexive. Now symmetric. So what is symmetric? Symmetric is nothing but if condition is there. So if a comma b exist, if we have some a comma b inside the relation, then b comma a must exist. B comma a must exist. But here in this case, the element a comma b itself is one element. So which means here a comma b itself is one element. So a comma b, if it is related with some other element c comma d, then c comma d should be related with a comma b. So this is what we have to check. So we have to take this as true, then we have to check whether this is true or not. So first thing, a comma b related with c comma d. So this we will take true. If then what I can write, a plus d equal to b plus c. The next thing here is I have to just check whether c comma d related with a comma b or not. If it is related, then what it will be, c plus d, this I have to add c plus d equal to d plus a. So here b will come, not d, b. So c plus b will be equal to d plus a. If we check these two things are true, because a plus d equal to b plus c, this we have taken true, which means c plus b will be equal to a plus d, both are same. So which means this is also belongs to the relation, which means it is symmetric. Next thing, now we will check for whether it is transitive or not. So in transitive, if a comma b related with c comma d and c comma d related with some e comma f, then we have to check, a comma b related with e comma f or not. So here if condition is there, so for transitive, if a comma b and b comma c exist, see here wherever it ends here it ends with b, here it starts with b. But here the element itself is an ordered pair. Here it ends with c comma d, here it starts with c comma d. The element itself is an ordered pair. So then what we have to do here is, then we have to check whether a comma c is there or not. Then a comma c must exist to be transitive, must exist. And here also it is the same thing. So now a comma b related with c comma d means I can write a plus d equal to b plus c. And c comma d equal to e comma f means I can write c plus f equal to d plus e. Now what I have to check here is, I have to check whether a comma b is related with e comma f or not, which means I have to just verify whether a plus f is equal to b plus e or not. If it is like this, then a comma b is related with e comma f. So now we can check that part now. So now if I take this as first equation and this is second equation, so just I am adding equation 1 and 2. So it will be a plus d plus c plus f equal to b plus c plus d plus e. So now in this case, this d plus d here and plus d here, it will get cancelled, and here we have plus c here and here also plus c, it will get cancelled. So now I will get a plus f equal to b plus c. So which means we got this one. So which means from here I can say a comma b is related with e comma f or e comma f. So which means I can say it is transitive. So now if it is reflexive, symmetric, transitive, so we have to just prove it is equivalence relation. Yes, if it is reflexive, symmetric and transitive, we can say since it is reflexive, symmetric and transitive, it is an equivalence relation. It is an equivalence relation. So next thing what they are asking here is also obtain the equivalence class of ordered pair 2, 5. So we have to find the equivalence class for this. So first we will see what is equivalence class. So equivalence class is nothing but, suppose if I ask equivalence class of A for any set. So A means equivalence class is a set first. Inside the set we have to write all the elements which is related with A. So which means A comma whatever we have here, so all the elements which is related with A, so all those elements I have to write here. Suppose if this is some B, C, D, so this B, C, D I have to write here. So this is equivalence class. But here what they are asking here is equivalence class of 2, 5. So which means what we have to write here is equivalence class of 2, 5. So we have to write all those elements which 2, 5 is related. So 2, 5 related with some A, B, we can say like this. So we have to write all the elements which 2, 5 is related. So if it is related, I can write 2 plus B equal to 5 plus A. So from here I can write B will be equal to 5 minus 2, which is 5 minus 2, 3, so 3 plus A. So now we know very well A also belongs to the set A. So this is nothing but A cross A, subset of A cross A. And this is also from A cross A, which means A belongs to set A, B also belongs to set A, C also belongs to set A, and D also belongs to set A. So which means I have to take A from 1, 2, 3, 1, it can be 1, 2, 3, 4, 5, like this, it keeps on going till n. A belongs to these elements. So which means if A is 1, I have to write inside the set equivalence class of 2, 5. So which means I have to write 1 here in place of A. So if I write 1 here, B will be 3 plus 1, it is 4. So next 2, 5, I can write 3, 6, I can write 4, 7, I can write 5, 8, I can write, and then 6, 9 I can write. I cannot write 7, if I take A value as 7, since B also belongs to that set A, so B will be equal to 7 plus 3, it will be 10, but 10 does not belongs to the set A. If 10 we have, then I can include this element. So I have to stop here itself. So this will be the equivalence class of 2, 5. So 2, 5 is related with 1, 4. 2, 5 is related with 2, 5 itself, since it is reflexive, and 2, 5 is related with 3, 6. So all these elements it is related. So from this we are completed the first question. Now we can start the second question. So in the second question it is also of the same model. So the second question, let n be the set of all natural numbers. So n is nothing but set of all natural numbers. So which means this set n is 1, 2, 3, 4, 5, it keeps on going like this. And relation on n cross n. See here, if they have given relation on n means it is subset of n cross n. Relation on n, if they have given, it is nothing but subset of n cross n. Since they have given relation on n cross n, which means the elements here itself is an ordered pair. So here this is nothing but a subset of n cross n cross n cross n. So it will be like this. So which means the set n cross n will be like this in this form. So it will be 1 comma 1, 1 comma 2, it keeps on going like this, 2 comma 1, 2 comma 2, and it keeps on going like this. Same thing, 3 comma 1, 3 comma 2, it keeps on going like this. Here also it keeps on going like this. So this is the set we have now. So from this set only we have to take the elements. So which means if it is reflexive, 1 comma 1 should be related with 1 comma 1. If it is reflexive, I can take 2 comma 7 also. 2 comma 7 is also one element. So it should be related with the same element 2 comma 7. So reflexive is nothing but any element if we take from that set, it should be related with itself. So now here what we have to prove here is a comma b is related with c comma d. This a comma b belongs to n cross n. N cross n. C comma d also belongs to n cross n. If it belongs to n cross n, this a will be some natural number and this b is also some natural number. Here c is also a natural number and d is also a natural number, which means I can say all a, b, c, d, all 4 belongs to some natural number. And here a comma b is related with c comma d if and only if ad equal to bc. In the previous question we just added a plus d equal to b plus c. Here we are not adding, here we are multiplying. So ad, a into d equal to b into c. Here we are multiplying. For all a comma b, c comma d belongs to n cross n. So this I have explained. And here also the same thing, show that R is an equivalence relation. Equivalence relation means I have to check whether it is reflexive, symmetric, transitive or not. So first I will erase this. So now in this part, a comma b related with c comma d if and only if AD equal to BC. This time I have to multiply. Now if it is reflexive, whatever element, this is one element, whatever element you have here, it should be related to itself. So which means I have to check a comma b related with a comma b or not. If it is related, then what I have to do here is from this I have to multiply this one. So which means AB equal to, from this B I have to multiply this one, so equal to BA. So which means we know multiplication is commutative. So if I take A belongs to some natural number, B also belongs to some natural number, which means if I take 2 and 7, so 2 into 7 will be same as 7 into 2, which means it is reflexive. It is reflexive. So next we will check for transitive. So for transitive, a comma b, this is one element related with c comma d. So this we are taking true, which means it exists. What we have to check? We have to check whether c comma d is related with a comma b or not. This part we have to check. This part we have to check. See here, if a comma b is related with c comma d, then what I can say from the question, AD will be equal to BC. So from here, if this is true, what I have to actually prove here is CB equal to DA. This is what I have to prove. And now from here, if you see this and this one, both are same. So BC can be written as CB. And here this AD can be written as DA. So which means I can say C comma D is related with A comma B. This is also true now. We verified. Okay. So which means it is symmetric as well. So now we have to check for transitive. So for transitive we should take 3 elements. So for transitive we have to take 3 elements. A comma b, I will take a comma b related with some c comma d, and I will take e comma f, whatever in transitive. See here, A related with B and B related with A. Then we have to check A related with C or not. B related with C here. And if you see here, this part B, it ends with B, it starts with B, then A should be related with C, which means here in this part it ends with C comma D. So whatever here B you have, in this place B we have C comma D, which means here it should start from C comma D. It should start from C comma D and it should be related with some E comma F. This part B here and here also B, it should be same. So we have to take these two things as true. If it is true, then what I can say from here, I can say this AD equal to BC, I can say from here, and from this I can say CF equal to ED, I can say. Then for transitive, what actually we have to check? A related with C. A is nothing but here if you compare A comma B is A. So we have to just check whether A comma B is related with E comma F or not. If it is related, what actually we have to prove here is I have to just prove AF equal to BE. So this is what we have to prove. So from here what I can say here is, I will take this as first equation and this is second equation. So just multiply these two equations. If I multiply this, AD into CF equal to BC into ED. From this some terms will get cancelled. So this D and here D will get cancelled. And here C, here also C, it will get cancelled. So which means I can say AF equal to BE. So this is what we have to prove. So if we have AF equal to BE, then A comma B is related with E comma F. So from here we proved it is transitive also. So we proved it is reflexive, symmetric as well as transitive. So which means I can say it is an equivalence relation. It is an equivalence relation, since we proved reflexive, symmetric and transitive. So now the second part of this question is, after proving it is an equivalence relation on n cross n, so find the equivalence class of 2 comma 6. So find the equivalence class, just now I have explained, equivalence class of 2 comma 6, equivalence class. So equivalence class of 2 comma 6 is nothing but all those elements which 2 comma 6 is related. So which means I have to write this inside the set, all those elements 2 comma 6 is related. I will take all those elements as some A comma B. If it is related with A comma B, then definitely this 2 into B will be equal to 6 into A. So which means I can say 2 into B is equal to 6 into A. So after that I can just solve this. 2 1s are 2 3s are 6. So B will be equal to 3 times A. See here, now A is some natural number. There is no end for natural number, which means the equivalence class, this is infinite set. In the previous question it was finite set, and here it is infinite set, because A I can take any natural number, 3 times some natural number is also a natural number. So B also can be any B also can be multiple of 3. So which means I can take A as 1, B will be 3, so 1 comma 3, 2 comma 6, 3 comma 3 3s are 9, 4 comma 12, 5 comma 15, then 6 comma 18. So there is no end for this, 6 comma 18, then dot 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 dot, there is no end for this. This is infinite set. So the previous question, the equivalence class is finite set, here it is infinite set. So now we can start the third question. So in this third question, a relation R is defined on set of real numbers. So this real number is nothing but rational union irrational. Rational number union irrational number. So we write real number in interval form. So it is from minus infinity to infinity. all 1.1, 1.2, all the numbers will be there. And here relation is defined as ordered pair x comma y such that x into y is an irrational number. See here, suppose if I take x equal to 1, because in real number I can take any number, y is also, y I can take 2, because real number 1 is also real number and 2 is also real number, and 1 into 2 is 2, this 2 is what? Rational, which means 1 comma 2 does not belongs to this relation. Now for reflexive, we have to just check whether it is reflexive or not. Now what I will do here is I will take x equal to 1 and y is also 1. So 1 into 1 is 1 only, 1 is rational. So which means from here, since 1 comma 1 does not belongs to the relation, it is not reflexive. It is not reflexive. Because in real number I can take 1 also, 1 belongs to real number. Next, symmetric. Symmetric is nothing but I have to take x comma y belongs to relation. So next I have to check whether y comma x belongs to relation or not. So this part we have to check. So if x comma y belongs to relation, which means x into y is irrational. If x into y is irrational, then what I can say, y into x is also irrational. This I have to write here. So y into x is also irrational. So if y into x is irrational, then I can say y comma x belongs to the relation. So it is symmetric. So it is symmetric. So next, coming to the transitive. So for transitive, A should be related with B, then whatever we have here same number, so B should be related with C. So then we have to check whether A is related with C or not. So for this we can take one example. So I will take the value of A as some root 5 and value of B as some 5 and value of C as some root 5 or 3 root 5. Now if we check A comma B belongs to relation, which because root 5 into 5 is irrational. And if we see here 5 into 3 root 5, which is 15 root 5, is irrational, which means I can say B comma C also belongs to the relation. So now we have to check whether A comma C belongs to relation or not, which means root 5 into 3 root 5. So we know that root 5 into root 5 is what? 5. So it will be 3 into 5, so it will be 15. So 15 is rational. So which means from here we got A comma C does not belongs to the relation. So what we have here actually is root 5 comma 5 belongs to the relation we have, 5 comma 3 root 5 belongs to the relation we have, but root 5 comma 3 root 5 does not belongs to the relation. So which means it is not transitive. It is not transitive. So if we see here this 5, here also we have 5 and here also we have 5. Same element we have, root 5 comma 5 belongs to the relation, 5 comma 3 root 5 also belongs to the relation, but root 5 comma 3 root 5 does not belongs to the relation. So it is not transitive. So now coming to the fourth question, it is from the functions. So now we can start functions. So before starting this fourth question, so first we can just see the introduction for functions. Functions. Function is a special type of relation. Function is a special type of relation. In this function, when a relation is a function, so domain should be equal to set A. This you have learned in your 11th standard. So domain should be equal to set A, and no two distinct ordered pairs, no two distinct ordered pairs should have the same first element, should have the same first element. So this is the definition of functions we have. So now there is another definition. For each input we should have exactly one output. For each input we should have exactly one output. Suppose for one input also, if we are having two different output, it is not a function. So for one input, if we are not having any output, then also it is not a function. Example, I will take one juice maker machine. So this is one machine. In this machine we can make juice maker machine. Now first time what I am doing here is I am putting apple in it. So I am getting some apple juice. This is my output, apple juice. So next what I am putting here is I am putting again apple I am putting. So second time I am getting mango juice. So which means my input was same, but I am getting two different output, which means this is not a valid machine. So I have like this apple comma apple juice, and second we have apple comma mango juice, apple comma mango juice. So it is like this. If I have to write this in arrow diagram, I have apple here, and apple is mapped to apple juice, and next I have again apple. So this apple is mapped to mango juice, which means one input is mapped to two different output. So which means it is not a function. Suppose if I put some mango in it, if I am not getting any output, then also it is not a valid machine, it is not a function. So this is the definition of functions we have. So for each input in the domain, suppose if we have 1000 elements in the domain, all those 1000 elements should have exactly one output in the codomain. So if for 999 elements we have exactly one output, but for the 1000th element we are not having any output, which means it is not a function. So the next thing here is we can have like this, two different input can have the same output. The example I can give here is, suppose if we switch on our mobile data, I am switching on my mobile data, output is we can use internet. As well as if I switch on my Wi-Fi, then also I can use internet. So two different input we have, but the output is same, which means we can use the internet. So from here we can say two different input can have the same output, but one input cannot have two different output. So this is function only. So this is the definition of functions we have. Suppose if I ask f of x equal to x by x, this is not a function, because if I put f of 0 is 0 by 0, so 0 by 0 is not defined, which means for all real number we have one output. If I put any real number here, so I will get one output except for 0. So if my domain is all real number, then it is not a function. If my domain is all real number except 0, then it is function. So real number is nothing but you have infinite numbers. In that infinite numbers, for all numbers it is function except 0. So if I include 0 here, it is not a function. So for one input also, if we are not having an output, it is not a function. So now we will see the types of function whatever we have. So types of function. So in this types of functions, so first thing we should know what is one-to-one. So the other name for this is injective. One-to-one is nothing but, suppose I will take one arrow diagram, and here in domain we have 1, 2, 3, 4, and here 11, 12, 13, 14 and 5 I have here. See here, 1-to-1 is nothing but if this 1 is mapped to 11, other than 1, no other element in the domain should map to the element 11. Suppose if I map this 2 to 11, it is also function only, but it is not 1-to-1 because this 2 is mapped to 11. Suppose if I map this 13, 4 here, 5 here, now it is function, but this function is not 1-to-1 because 1-to-1 says if 1 is mapped to 11, other than 1, no other element in the domain should map to the element 11. So which means it is not a 1-to-1 function, injective. So if this 2 is mapped to 12, other than 2, no other element in the domain should map to the element 12. So if 3 is mapped to 14, other than 3, no other element in the domain should map to 14. So if 4 is mapped to 13, so then other than 4, no other element in the domain should map to 13. Now if I map this 5 to 15, it is not 1-to-1 now, which means from here I can say number of elements in set A should be lesser than or equal to number of elements in set B, which means I should have some 15, 16 here. Some extra elements can be there in set B, but not less. So now 5 can map to 15, now it is 1-to-1. The condition for 1-to-1 is number of elements in the domain should be lesser than or equal to number of elements in the codomain. Now if we see here, the inverse is not a function here. Inverse is nothing but domain will change to codomain and codomain will change to domain. So set B will come here and set A will be here. So it will be 11, 12, 13, 14, 15, 16 here, and here 1, 2, 3, 4, 5. And 11 is mapped to 1, 12 is mapped to 2, and 13 is mapped to 4, and 14 is mapped to 3, and 15 is mapped to 5. And for this 16 there is no image, which means it is not a function. So from here, if it is just 1-to-1, the inverse is not a function. This is f and this is f inverse. So now the second thing we will go for onto. So onto is nothing but surjective. So in onto, range will be equal to codomain. So here itself I will tell what is range. Range is nothing but all those elements which have pre-image, which means in set B all those elements which is mapped with A, so all those elements we call as range. So 11 is mapped, 11 has pre-image, 12 has pre-image, 13 has pre-image, 14 has pre-image, 15 has pre-image. But if we ask codomain, codomain is nothing but 11, 12, 13, 14, 15, 16. So here range is not equal to codomain. If range is equal to codomain, then we can say it is surjective onto. So for onto, range should be equal to codomain. So here I will take one example here, 1, 2, and here 3, 4, 5. So 1 is mapped to 3 and 2 is mapped to 4. Now range is not equal to codomain, which means this 5 should have some pre-image. If I map this 2 to 5, it is not a function because 2 has two different output. One input cannot have two different output, which means it is not a function. So what I am going to tell here is number of elements in A should be greater than or equal to number of elements in B for onto function. So 3, 4, so this 3 also I can map as well as 4 also I can map. So inverse, what about the inverse? Inverse is nothing but codomain will change to domain and domain will change to codomain. So here it will be 1, 2, 3, 4. So 3 is mapped to 1, 4 is mapped to 2, and 5 is mapped to 3 as well as 4. One input has two different output, not a function. not a function. So now what is the general thing to prove one-to-one? F of x1, see here, I'll take x1 here, x2 here, and here some y1. x1 also map to y1 and x2 also map to y1. This x1 and x2 is some general element. So now what I'm telling here is f of x1 equal to f of x2, which means just now I told if 1 is mapped to 11, other than 1, no other element should map to 11, which means if x1 is mapped to y, other than x1, no other element should map to y, which means these two elements are not different, so it is exactly equal. This is what we had to prove. So if f of x1 equal to f of x2, we have to just prove x1 equal to x2. So for on to, just we have to check all the elements f of x equal to y. This y is all the elements in codomain. Any element if I take from codomain, corresponding x should be there in the domain. If we have like that, then we call that as onto function. And now next we will see when inverse will exist. See here, if it is just 1-to-1, inverse does not exist. If it is just onto, inverse does not exist. So inverse will exist if the function is bijective. Bijective is nothing but it is both 1-to-1 as well as onto. So 1-to-1 is nothing but this condition, n of a lesser than or equal to n of b, n of a greater than or equal to n of b. So if we combine both, then n of a will be equal to n of b, so that will be the bijective function. Now coming to the fourth question. So now let's set a equal to all real number except 3 and set b equal to all real number except 1. Be two sets we have. Prove that the function from a to b given by f of x equal to x minus 2 by x minus 3 is onto, is the function f 1-to-1, that we have to check. So we have to prove it is onto. Onto we have to prove. Next we have to check whether it is 1-to-1 or not. So first we will check whether it is 1-to-1 or not. So for 1-to-1, f of x1 should be equal to f of x2. 1-to-1. F of x1, this is the condition I have written. If f of x1 equal to f of x2, this we have to prove x1 equal to x2. Okay, for 1-to-1. If we cannot able to prove, then it is not 1-to-1. So now I will take f of x1 equal to f of x2. Now before starting, if it is given all real number, then it is not a function, which means we cannot able to find other things. Okay, so here they have given all real number except 3. So why I am saying if it is all real number, it is not a function? Because if I put 3 here, if my 3 is my input, x 3 minus 2 1, so 1 by 0, which is not defined. So for input 3 we are not having an output, which means it is not a function. So here all real number except 3 we have, which means it is a function. I will take f of x1 equal to f of x2, so which means f of x1 is x minus 2 by x minus 3, and here it is x1 minus 2 by, here is this, x1 minus 2 by x1 minus 3 equal to x2 minus 2 by x2 minus 3. So now we have to just solve this, just we have to multiply. So x1 minus x2 into x2 minus 3 equal to x2 minus 2 into x1 minus 3. Now what I can do here is, just I can multiply in this order. So it will be x1 x2 minus 3x1. So minus x2 square, then minus into minus plus, plus 3x2 equal to, next this one, so x1 x2 minus 3x2 minus 2x1 minus into minus plus, so plus 6 will be there. And here also I have x1 x2, here also x1 x2, and here also x1 x2. So the next thing here is, next I can take something common, so it will be minus 3x1, next it is minus x2 square plus 3x2, and if this comes here it is plus 3x2 plus 2x1 minus 6 equal to 0. And this is x1 minus 2. So which means x1 x2 minus, so minus 2x2. This is minus 2x2 and this is plus 6, which means I can erase this. So minus 2 plus 6 and plus 6 will get cancelled. So now I can bring everything to the LHS. Minus 3x1 minus 2x2. So plus 3x2 plus 2x1 equal to 0. So minus 3 plus 2 minus x1 minus 2 plus 3 plus x2 equal to 0. So if this comes here, x1 will be equal to x2, which means it is 1 to 1. It is injective. Next we have to prove it is onto. Onto means, so onto means f of x is equal to f of y. F of x is equal to y. So what is f of x? We have x minus 2 by x minus 3. X minus 2 by x minus 3 equal to y. See here, y is written in terms of x. For onto, I have to write x in terms of y. So x minus 2 equal to yx minus 3y. So x equal to in terms of y I have to write. So this I can bring here and this I can bring here. So x minus yx equal to 2 minus 3y. And now I can take x common. So if I take x common, it will be 1 minus y equal to 2 minus 3y. So x will be equal to 2 minus 3y divided by 1 minus y, which can be written as 3y minus 2 by y minus 1. So now this part, now I have to check this y minus 1 cannot be equal to 0 and y not equal to 1. This is what they have given in the codomain part. In codomain part, they have given all real number except 1. Yes. Suppose if this condition, if it is not given, I cannot say it is onto. So here this condition is also given, all real number except 1, which means codomain will be equal to range. So if codomain is equal to range, then we can say f is onto. Onto I can say, or I can say surjective. So this is what we have in this question number 4. So now we can start the question number 5. So in this question number 5, we had to prove function from 0 to infinity. See here, 0 to infinity is nothing but they are telling positive real number. I can say non-negative real number. Non-negative real number. In non-negative real number, 0 is also included. Positive real number means 0 is not included, so only I have written non-negative real number. Okay, and the codomain is minus 5 to infinity, and f of x is given as 4x square plus 4x minus 5 is both 1 to 1 and onto we have to prove. So we have to prove, the answer is given, we have to anyway prove it is 1 to 1 and onto. So 1 to 1 means f of x1, if f of x1 equal to f of x2, then we have to prove x1 equal to x2. So first we will start with f of x1 equal to f of x2, which means wherever x we have to put x1. So 4x1 square plus 4x1 minus 5 equal to 4x2 square plus 4x2 minus 5. From here, this minus 5 and this minus 5 will get cancelled. Now from here I can divide by 4. I can divide by 4, or I can take 4x1 square minus 4x2 square plus 4x1 minus 4x2 equal to 0. So 4 I am taking common, then x1 square minus x2 square, this is one term I am taking, plus divided by 4, so this will go, so x1 minus x2, like this I am taking, it is equal to 0. So 0 by 4 is 0. So a square minus b square form, which means x plus x1 plus x2 into x1 minus x2 plus x1 minus x2 equal to 0. So from here what I can do here is I can take this x1 minus x2 common. So it will be x1 minus x2 common. If I take, it will be x1 plus x2 plus 1 equal to 0. See here, if we have some a into b equal to 0, either a or b will be 0. So which means either this x1 minus x2 will be equal to 0, which means I got x1 equal to x2. After getting this, we should not stop. We have to check whether this is also x1 equal to x2 or not. So from here, x1 plus x2 equal to minus 1, which means I cannot get, we are not getting x1 equal to x2 from this. We are not getting x1 equal to x2 from this. Okay, which means from here, before telling it is not reflexive, we have to go to the domain. Domain is what? 0 to infinity. So 0 to infinity means non-negative integer. After adding, x1 belongs to 0 to infinity. x2 also belongs to 0 to infinity, which means if we add two non-negative integer, it cannot be equal to minus 1. So which means this is not possible. Suppose same question, if they have given this as real number, it is not 1 to 1. Because in real number, I can take x1 as minus 1 and x2 as 0. It will be equal to minus 1. So in this case, since they have given it starts from 0 to infinity, we cannot have this minus 1. So only we can say it is reflexive. Suppose if the same question, if they have given all real number, it is not 1 to 1. Okay. So now we can start prove this onto function. So for onto, we have to prove codomain equal to range or range equal to codomain. So we have to find the range for this, which means f of x equal to y. So in this f of x equal to y, I have to write y is in terms of x. I have to write x in terms of y. So this is, I have to write x in terms of y. So what is given in the question is y equal to 4x square plus 4x minus 5. Y equal to 4x square plus 4x minus 5. So whenever if we have quadratic equation in this form, so we have to write x equal to means we have to find the roots. So roots ax square plus bx plus c means if we have ax square plus bx plus c equal to 0 should be there, then x will be equal to minus b plus or minus root of b square minus 4ac by 2a. So this we can use if we have equal to 0, which means first bring this plus y here, it will be equal to minus y. So 4x square plus 4x minus 5 minus y equal to 0. So now you have to consider y as some constant in this c part. Okay. And coefficient of x square, now we have to compare this ax square plus bx plus c. In this I have to compare, in this a will be equal to 4 after comparing, b is also 4, c is minus 5 minus y, which means minus of 5 plus y. So now I can directly use the formula. So x will be equal to minus b, which is minus 4 plus or minus root of b square, which is 16 minus 4 into a, which is 4, and c minus is there, so minus into minus plus c, which is 5 plus y, divided by 2 times a, 2 into 4. So this is what we have in this. Now we have to simplify this. So in this 4 4s are 16, I can take 16 common inside the square root. So minus 4 plus or minus root of 16, if I take common, it will be 1 plus 5 plus y. So it will be root 16 is 4. So it will be equal to minus 4 plus or minus 4 into root of y plus 6 divided by 2 into 4. This 4 I can just cancel. So x will be equal to minus 1 plus or minus root of y plus 6 divided by 2. So which means now x will be equal to minus 1 plus root y plus 6 by 2. Next, x will be equal to minus 1 minus root of y plus 6 by 2. We have two values for x. See here, this value is not possible. The reason is, in the question they have given x belongs to 0 to infinity. X is nothing but domain, so x belongs to 0 to infinity, which means non-negative integer. So here minus, if I take 1 by 2 common also out, minus 1 minus again, we are subtracting again, which means this value will be negative. If this is negative, we cannot take, this is not possible, which means this only is possible. We have x equal to minus 1 plus root of y plus 6 by 2. So this will be, I have written x in terms of y. Now from the domain, if x is greater than or equal to 0 we have. So x greater than or equal to 0 means whatever value you have here, this will be greater than or equal to 0. So if this goes here, 2 into 0 is 0 only. So minus 1 plus root of y plus 6 should be greater than or equal to 0. If this comes here, it is plus 1. So root of y plus 6 is greater than or equal to 1. So this we have. So now what we can do here is squaring on both sides. Squaring on both sides. So after squaring on both sides, we will get y plus 6 greater than or equal to 1. So which means y greater than or equal to 1 minus 6, y greater than or equal to minus 5. Minus 5 means y belongs to minus 5 to infinity. This is my range. I have to just check whether this is equal to codomain or not. So minus 5 to infinity, yes. So codomain is also minus 5 to infinity, which means we got range equal to codomain. So it is on 2. That's all. So this will be the answer for the 5th question. So now we can start the 6th question. So in this question number 6, we have to check whether a function domain is all real number here and codomain is minus 1 by 2 to 1 by 2, where minus 1 by 2 and 1 by 2 is included, defined as f of x equal to x divided by 1 plus x square is 1 to 1 and on 2. So we have to just check whether it is 1 to 1 and on 2 or not. So first we will go by 1 to 1. So for 1 to 1, what is the condition? If f of x1 is equal to f of x2, then we have to check whether x1 is equal to x2 or not. So now what I will do here is, f of x1 is what, in place of x we have to put x1. So x1 divided by 1 plus x1 square equal to x2 divided by 1 plus x2 square. So this part I will multiply here, cross multiply, x1 into 1 plus x2 square equal to x2 into 1 plus x1 square. So now what I will do here is, I will just multiply this here. So it will be x1 plus x1 x2 square equal to x2 plus x2 x1 square. So bring everything to left hand side, LHS. So what we will get here is x1 minus x2 plus x1 x2 square minus x2 x1 square equal to 0. So this x1 minus x2 I will take this as one term, and here I can take x1 x2 as common. If I take like this, so it will be x2 minus x1 I will get equal to 0. Now if I take x1 minus x2 common, here in this I have into 1 like this. So this into 1 I can write here, and this is nothing but negative of x1 minus x2. So which means I can write this as minus x1 x2 equal to 0. So now, as I told, if we have two numbers, if a into b is equal to 0, then either a will be 0 or b will be 0, which means this x1 minus x2 will be equal to 0. This is one possibility. After getting this, I cannot say it is 1 to 1. I have to come to the next one. So 1 minus x1 into x2 equal to 0, which means if this goes here, it will be x1 into x2 equal to 0. x1 into x2 equal to 1. So x1 into x2, if it is equal to 1, so in which case if we take two numbers, the product is 1. If x2 is reciprocal of x1, reciprocal of x1. So we are in real number. In real number, if you take any number, the reciprocal of that number is also present, which means if I take a number 1 by 3, the reciprocal of 1 by 3, 3. So both are real number only, which means 3 and 3 will get cancelled, it will be equal to 1. So what I am telling here is, whatever value if we are getting for 1 by f of 1 by 3, let's say the value is a, same value we will get for f of 3 also, it will be equal to a, which means two different input has the same output, which means it is not 1 to 1. It is not 1 to 1. Now same question, instead of real number, if we have natural number. So in natural number, if we take any number, any natural number 3, the reciprocal of this 3, 1 by 3 is not natural number, which means x1 into x2 cannot be equal to 1 if x1 is not equal to x2 in natural number. So if they have given the same question, in place of this real number, if they have given natural number, in this case it will be 1 to 1. Since they have given real number, in real number, if we take any number, the reciprocal of that number is also present there. Suppose if I take 0.3, the reciprocal of 0.3, 1 by 0.3, again it is one real number. But here in natural number, if I take 5, the reciprocal of 5 is not a natural number. So which means x1 into x2 cannot be equal to 1 unless x1 is equal to x2. x1 is 1 and x2 is 1. Okay, in other cases it is not. Suppose if I take x1 as 2, 2 is natural number, 2 into 2 is what, 4, which means this is not valid if it is natural number. Then I can say it is 1 to 1, because we have one condition, x1 is equal to x2 already. Okay, so now this is not 1 to 1. Now we have to check for onto also. So for onto, f of x equal to 1 plus x square, x divided by 1 plus x square. So it is equal to y. So y is given in terms of x. So we have to write x equal to, in terms of y we have to write, in terms of y. So this is what we have to write here. So if we cross multiply this, so x will be equal to, so y plus x square y. So now x equal to, if we have to write, so this is one quadratic equation. So I can write this quadratic equation in this form, x square into y, x square, then here x and the constant term. So here we have yx square, and here this constant is minus 1, and here it is plus y equal to 0. So this is quadratic function in terms of x. So I can use the formula minus b plus r minus root of b square minus 4ac by 2a, and x will be equal to, so I will just compare this first, ax square plus bx plus c equal to 0. So a will be equal to y here, and b is equal to minus 1, and c is also again it is y. So x will be equal to minus b, minus of minus 1 plus 1, plus or minus root of b square, which is 1, minus 4 into a into c, which is y square. So divided by 2a, so 2y. So this is what we have. So x we have written in terms of y. So this is valid if whatever we have this inside the square root, this should be greater than or equal to 0, which means 1 minus 4y square should be greater than or equal to 0, which means I can write in this way. So 1 square minus 2y the whole square greater than or equal to 0. So this is of the form a square minus b square. This if I factorize, so 1 plus 2y into 1 minus 2y greater than or equal to 0. So now I have to find the roots for this. See here, greater than or equal to 0 means this 1 plus 2y should be greater than or equal to 0 and 1 minus 2y should be greater than or equal to 0, or this 1 plus 2y should be lesser than or equal to 0 and this 1 minus 2y should be lesser than or equal to 0. Greater than or equal to 0 means this should be positive. So positive into positive is also positive and negative into negative is also positive. So only we have taken both greater than or equal to 0 and here we have taken both lesser than or equal to 0. Or we can use wavy curve method, which means we have to find the roots for this. So 1 plus 2y equal to 0 means 1 plus 2y equal to 0 means, so y will be equal to minus half, and 1 minus 2y equal to 0 means y will be equal to half. So here we have minus infinity and here we have plus infinity. So we have to take any number in between this minus infinity to minus half. I can take minus 1. So if I take minus 1, I have to just check whether this satisfies this inequality or not, this one. So after checking, I can take minus 1. So 1 minus 2 into 1 plus 2. So 1 minus 2 is minus 1. So minus 1 into 3, it is negative. So this is negative. But we should get positive here. Greater than or equal to 0 we have, which means this we cannot include in the solution. So next, minus half to half, I can take 0. So 0, if I take 1 into 1, it is positive, which means this is positive, which means I can include this in the solution. So 1 by 2 to infinity, I can take 1. So 1 plus 2, 3. So 1 minus 2, it is minus 1. So it is negative. So which means I cannot include this in solution. So my range will be equal to minus 1 by 2. Here greater than 0 is not there. Greater than or equal to 0 is there, which means minus half and plus half I can include. So range will be equal to minus half to half, and I have to check what is my codomain. If the codomain is also the same thing, then we have done. So yes, codomain is also minus half to half. Codomain is also minus half to half. So which means I got range is equal to codomain. So it is onto. So we have to just check whether it is one-to-one and onto or not. Yes, it is both one-to-one as well as onto. So which means it is bijective function. I think it is one-to-one. Yes, it is not one-to-one. So which means it is not bijective, because here it is not one-to-one. So now we can start the next question, 7th one. A function from minus 4 to 4, domain is minus 4 to 4, to 0 to 4 is given by f of x equal to root of 16 minus x square. Show that f is an onto function but not one-to-one. Okay. See here, if I take one-to-one is nothing but f of x1, if f of x1 is equal to f of x2, then x1 is equal to x2. So if it is not one-to-one, if I prove in this way, f of x1 equal to f of x2 we have, but see here, if it is not one-to-one, I can able to prove f of x1 equal to f of x2, but x1 is not equal to x2. So this is what I had to prove here. Now suppose if it is from minus 4 to 4, take any point here, minus 4 we have and here 4 we have. Any point you can take in between this minus 4 to 4. Let's take minus 2 and plus 2. So negative of that number and positive of that number. So this point we have to take. Now just substitute f of minus 2 and find the value, and here also f of 2. The reason why we are doing this is because here x square term is there. So minus 2 square is also 4 plus 2 square is also 4. So only I am taking one number, negative of that number and positive of that number. So I can take minus 3 and plus 3. I can take minus 3.1 plus 3.1. I can take minus 2.3 plus 2.3. Any number, because it is real number, so I can take in fraction also. So it is f of minus 2 will be 16 minus 2 the whole square. So which is minus 2 the whole square is 4. So minus 4 will be there. So which is, it is 16 minus 4 root 12. So here 2 if I put, it is again 16 minus 4 root 12, which means f of x1 equal to f of x2 I got, but f of minus 2 is equal to f of 2, but minus 2 is not equal to 2, which means it is not 1 to 1. It is not 1 to 1. So now we have to check whether it is onto or not. So show that f is onto, which means it is onto, we have to prove that, but not 1 to 1. So this we have proved. So we have to prove it is onto. So for onto, what we have to do here is, so here we have to prove onto. So onto is nothing but range should be equal to codomain. Onto, so range should be equal to codomain. So what is codomain we have? So codomain equal to, we have it is 0 to 4, 0 to 4, and the function y is equal to root of 16 minus x square, root of 16 minus x square. So this y is greater than or equal to 0 first, because our domain is minus 4 to 4. If we put any value in between minus 4 to 4, so it is 0 to, so it is greater than or equal to 0 we have. So the domain is from minus 4 to 4. Now it is greater than or equal to 0. Now if we have x square equal to 1 suppose, then x will be equal to plus or minus 1. If we have x equal to root 1, in this case plus or minus will not come. These both things are not same. So here plus or minus will not come. X will be equal to plus 1 only. So you know this is quadratic. Quadratic means two roots will be there. So only we will write x equal to plus or minus 1. And x equal to root 1 means this is linear, which means only one solution will be there. There is a difference between x square equal to 1, after taking square root plus or minus will come x equal to plus or minus 1, and x equal to root 1 directly if we have, x will be equal to 1, plus or minus will not come. Suppose x equal to root 4 if I have, so x will be equal to 2, not plus or minus 2. Suppose if I have x square equal to 4, in this case x will be equal to plus or minus 2. So quadratic means two roots will be there, linear means only one root will be there. And here we have only square root. First this part will be greater than or equal to 0. Now we have to write this y is given in terms of x. Now I have to write x in terms of y, in terms of y. So now what I will do here is I will do squaring on both sides. So y square equal to 16 minus x square, which means from here x square will be equal to 16 minus y square. So then x will be equal to root of 16 minus y square. So this part, whatever we have inside the square root, this should be greater than or equal to 0. So which means y square is lesser than or equal to, if this y square 16 greater than or equal to y square, so y square is less, y square minus 16 is lesser than or equal to 0 we have. So this is coming here, so y square minus 16 lesser than or equal to 0, or I can just multiply with minus 1 here, the inequality will be reversed if we multiply by a negative number. So the next thing here is, now if I factorize this, it will be y plus 4 into y minus 4 lesser than or equal to 0. The roots we have here is minus 4 and 4. So here minus infinity to infinity we have, and here minus infinity to minus 4 one interval, minus 4 to 4 one interval, and 4 to infinity one interval. I have to just check which part will satisfy this. So now if I take any value in between this, I can take minus 5. So minus 5, if I take minus 5 plus 4, it is negative, and it is also negative, so it is positive, which means this part will not come because I should get negative values. And y belongs to, if I take any value in between minus 4 to 4, if I take 0, so 0, 4 here and here minus 4, it is lesser than or equal to 0, which means I can take any value in between minus 4 to 4, and 4 to infinity, if I take 5, one is positive and the another one is 5 minus 4, two of them are positive, which means it cannot be lesser than or equal to 0. This also I cannot take. So y belongs to minus 4 to 4. As well as we have y greater than or equal to 0 here itself, which means after combining these two both, minus 4 to 4, this entire thing, minus 4 to 4, this part from here to here, and in between 0, so greater than or equal to 0, this entire thing, the intersecting part only we have to take. So y belongs to 0 to 4. So this is the final one, final range, and codomain is also 0 to 4. So which means range equal to codomain we got. So if range is equal to codomain, then it is onto. So that's all. So now we can do the last question in this relations and functions chapter, the 8th question. So let function from all real number except minus 4 by 3. The reason why we are removing this minus 4 by 3 is this denominator cannot be equal to 0. So which means this 3x cannot be equal to minus 4. So this x cannot be equal to minus 4 by 3. So be a function defined by f of x equal to this thing is given. Show that f is 1-to-1 function. Also check whether f is onto function or not. So here first we will prove 1-to-1. So 1-to-1 is nothing but f of x1 equal to f of x2 if we have to take this one. Then we have to prove x1 is equal to x2. So this we have to prove. Now first what we will do here is f of x1 equal to f of x2 we will take. So in place of x we have to put x1. So 4x1 by 3x1 plus 4 equal to 4x2 divided by 3x2 plus 4. So now we can just cross multiply this. 4x1 into 3x2 plus 4 equal to 4x2 into 3x1 plus 4. Now just we can multiply this. So 4 3s are 12, 12 x1 x2 plus 4 4s are 16 plus 16 x1 equal to 4 3s are 12, so 12 x1 x2. Next 4 4s are 16 plus 16 x2. From here this and this will get cancelled. If this comes here, it is minus 12 x1 x2, this will get cancelled. So now what we have here is 16 x1 equal to 16 x2. So after this 16 and 16 will get cancelled. I got x1 equal to x2. So which means f is 1-to-1, which means it is injective. So next thing we have to check here is whether f is onto or not. So onto means f of x equal to y should be there. So first y is written in terms of x. So we have to write x in terms of y. So from here y is equal to 4x divided by 3x plus 4. 4x divided by 3x plus 4. So if we have to write this as x equal to, just we have to multiply this y times 3x plus 4 equal to 4x. So from here 3yx plus 4y equal to 4x. So x terms we have to take in one side. So 3yx minus 4x equal to minus 4y. So x I can take common. After taking x common, it will be 3y minus 4 equal to minus 4y. So x will be equal to minus 4y divided by 3y minus 4. But this denominator cannot be equal to 0, 3y minus 4 cannot be equal to 0, which means 3y cannot be equal to 4. So y cannot be equal to 4 by 3. So range can be all real number except 4 by 3. But here the codomain, they have not given R except all real number except 4 by 3. So they have given all real number. So codomain is all real number. So which means we can say range is not equal to codomain. So F is not onto. If it is not onto, then it will be into. So if it is not 1 to 1, then it is many to 1. If it is not onto, then it is into. So from this we completed the relations and functions chapter. So next we can start matrices in next class.